The purpose of this exercise is to give you experience finding the probability of different events using binomial and normal distributions. If you recall from the textbook, Company P, the paper products manufacturer, has a customer service and return department. A customer service representative's records show that the probability of a newly sold product needing to be returned in the first 90 days is 5%. If we select a sample of 3 new products, we want to find the probability that none of them need to be returned, the probability that at least one needs to be returned, and the probability that more than one need to be returned. So we'll need to use the binom dist function in Excel to arrive at the answers to these 3 probability questions. Let's first remind ourselves that the number in the sample we've selected is 3, and that the probability of success, or here the probability of a newly sold product being returned in the first 90 days is 5%. So those are the parameters we will need when we're using our functions. To get the probability that none of the products will be returned, we use our binom dist function in Excel, and we want to know the probability that 0 and only 0 are returned. So 0 is our number. We know that our trials is 3 and the probability is 5. And we're going to say false for the last argument because we only want the probability of that single event, none, happening. We don't want any cumulative effects. So the probability of none of the products being returned is 85.7%. Next, we want to find the probability that at least one of the products is returned. To arrive at that probability, we have to consider what we need. So we need to know at least one, which means one or more. So there are a couple of ways to do this. The first is to take 1 minus the probability of 0 products being returned. That would return the probability that at least one will be returned. To do that, we simply do 1 minus our binom dist function for 0 products being returned. And again, we use false as for the last argument because we want the probability that 0 and only 0 products are returned. Doing 1 minus this binom dist function will give us the probability that at least one is returned. So we get a probability of 14.3%. So that is the probability that at least one product will be returned. Last, we want to find the probability that more than one product will be returned. The other way to arrive at least one product being returned is to take 1 minus the probability that up to 1 products are returned. So we will use the true argument. Plus the probability that exactly 1 product will be returned, which requires the false argument. So this string of functions will also give us the probability that at least one product is returned. And you can see we do get the exact same answer. The probability is 14.3%. Last, we will look at how to find the probability that more than one product is returned. To get more than one, it means that we want the probability that 2 or more are selected. So to arrive at that solution, we can do 1 minus the probability that up to 1 products are returned. And this will give us the probability that more than one products are returned. We arrive at an answer of 0.007. So therefore, it is not very likely that more than one product will be returned. In fact, it's slightly less likely than the probability of at least one product being returned, and much less than the probability of no products being returned. In the next example, Company S, the accounting firm, knows that to resolve client inquiries on the same day is highly important for keeping client satisfaction. This means the client relations department works quickly to resolve inquiries on the same day. Past data from the Customer Relationship Management Database indicates that the likelihood is 70% that client inquiries that come in on a Monday, the busiest day of the week, will be resolved on the same day. So for the first 5 inquiries submitted on a given Monday, we want to find the probability that all 5 will be resolved in the same day, the probability that at least 3 will be resolved in the same day, and the probability that fewer than 2 will be resolved on the same day. So let's remind ourselves that the number of trials is 5, and the probability of success is 70%. Those parameters will be helpful when we go to use our binom dist functions in Excel. So in order to find the probability of exactly 5, we're going to want to use the false argument in our binom dist function. We want to find exactly 5 with 5 trials with a success rate of 70%, and we don't want that to be a cumulative effect. We want it to be exactly 5. So we see the probability of all 5 being resolved on the same day is 16.8%. To find the probability of 3 or more, we can take 1 minus the probability of up to 2. So we're going to use the true argument because we want the cumulative probability up to 2, and 1 minus that will give us the probability for 3 or more. We get a probability of 83.7%. Finally, we want to find the probability that fewer than 2 will be resolved on the same day. To arrive at that solution, we take the probability of up to 2 minus the probability of exactly 2. And this will give us the probability that fewer than 2 are completed on the same day, which is about 3%. Now we could also arrive at the same solution by finding the cumulative probability for 1. So this time we use the true argument. And we arrive at the exact same percentage of about 3%. So that is how you can use the binom dist function in Excel to find the probability of different events in a binomial distribution. Now we're going to solve probability problems in Excel using the functions for normal distributions. The problem in the book states that Company P has determined that its truck drivers making deliveries are spending a lot of time on the road, and the trucks are becoming worn out quickly. Company P determined that the annual distance traveled per truck is normally distributed with a mean of 72,000 miles and a standard deviation of 17,000 miles. So I have entered here into Excel the mean and standard deviation so that we can recall them when we need to, as well as the parameters for each of the 4 problems. For the first problem, we want to find what proportion of the trucks can be expected to travel between 38,000 and 62,000 miles in the year. So what we will need to do is first find the probabilities for each of the mile values. To do this, we could enter the formula into Excel by hand, or we can go up to the Formulas tab and select Insert Function. Here we can search for the function we'd like to use, or if we use it frequently enough, it'll be in the box below displaying the most recently used functions. We would like to use the norm dist function, So we can highlight it in the box and click OK. So the first thing we need to do is enter our x value into the x box. We will first find the probability for 38,000 miles. So we type 38,000 in the x box. Next, we will enter our mean and standard deviation. And then we would like to enter the true statement for the cumulative box. We can see that we get a probability of 0.02. And when we click OK, it's entered into the cell for us. We can also refer to the formula bar to remind ourselves of exactly what the function was that we used to arrive at the value presented in the cell. Now we will do the same for 62,000 miles. Except this time we will put 62,000 in the x box. And we again want the true statement. The probability for 62,000 miles is 0.278. Now, in order to get the proportion of trucks that travel between these 2 mile values, we need to subtract one from the other. So we're going to take the probability for 62,000 miles, which is located in column B, row 5, and subtract from it the probability for 38,000 miles, located in column B, row 4. And we get an answer of 0.255. So that is the proportion of trucks that can be expected to travel between 38,000 and 62,000 miles in the year. Next, we would like to find what percentage of trucks travel less than 35,000 miles in the year. To do this, we go back to Insert function and enter 35,000 miles in the box. As well as our other parameters. And we still would like that true statement because we want the cumulative probability up to 35,000. We get an answer of 0.01. So that is the percentage of trucks that will travel less than 35,000 miles in the year. Next, we'd like to find the percentage of trucks that travel more than 57,000 miles in the year. To do this problem, we have to first find the value for up to 57,000. And then take 1 minus that value to arrive at the percentage of trucks that travel more than 57,000. We could also do this manually by entering into the cell 1 minus the normdist function for 57,000 miles with a mean of 72,000, standard deviation of 17,000, and the true statement. And we arrive at the same answer of 0.811. The last problem would like for us to find the mile value that separates the lower 72% from the top 28%. To do this, we use the norm inverse function. Here we must enter the desired probability, which in this case is 0.72, and our known mean and standard deviation. And we get a mile value of 81,908. And that is how you can use the probability functions in Excel to work with normal distributions.